Welcome to the Night Club, guys. It's your host, the Night Wrencher. I've actually tried to make this video like 3 or 4 times and I just can't get it simply enough. So I'm going to go ahead and give it another shot. Today we're actually going to be learning how to set up your machines to weld flux core wire. My particular machine is the Omni Pro 220. It's made by Vulcan. It's a Harbor Freight welder, so you can actually do this with your Lincoln welder, your Hobart, your Miller, your whatever. You can even do this with the cheaper Harbor Freight ones. It doesn't really matter. It ends up working the same. Like I said, this is a Vulcan 220 and this one is using flux core wire. Just to double check, we're going to go ahead and look in here. This particular wire is 035 Lincoln electric wire, the inner shield wire. I do like the Lincoln wire. I don't like the Harbor Freight wire. So this machine came with Harbor Freight wire and I was having a lot of issues and it was really nasty. I didn't really like it. So I ended up going with the Lincoln wire. And just so you guys understand that this is gasless, zero gas. I don't have anything hooked up to the gas inlet of my machine. I am hooked up to a 110 power source right there. Before you start welding flux core or anything, you make sure your machine is welding DC electrode negative. So the ground wire here that's hooked up to my table is actually at the positive, and the negative circles back around into the machine, and that's for my gun. So as long as you've got that, everything else is good to go. So we're actually looking at 2 different things here. We're looking at speed, wire speed, and we're looking at voltage or heat. So moving on to the actual fun part of this whole situation, we are going to learn how to do some welding and setting up the basic settings on your machine. So as you guys can see, I've done a bunch of different little test beads using different settings, so that way I can understand what we're working with a lot easier. That one was really hot. Basically, like I said, we've got 2 settings. One determines how much material is getting built up. For example, this one right here in the corner, you guys can see it's got a really high profile. It was going way too fast. And then we've also got this one over here that looks almost molten, like molten metal. This is actually a sign that you're running way too hot. How do you actually go about determining what are the proper settings? Setting up your welder for the first time can be a little bit tricky because it does end up being like kind of a seesaw effect. You go up in wire speed, you might have to go up in heat. Because you go up in heat, you want to go up in wire speed, and it kind of just keeps doing this. The best way to go is actually look up the settings for your machine. Usually manufacturers will tell you what to set it on depending on what the thickness of your material is. Some machines have the recommended settings in the inside flap of the machine. This one does not, because the settings are actually programmed into it right here. So if we go flux core, it says no gas required. Actually, it says right here ground clamp goes on positive, just like I said before. And then you put in the type of wire. This is 035, and then we are welding 16 gauge. Oops, wrong knob. 16 gauge, confirm, and then it gives you the base settings, 110 at 16.5. And so this is inches per minute. Not all machines are the same. Some have like a 0 through 10 dial, some have a 1 through 10, some have a 1 through 5, some have an ABCD, some just have a fast and slow. So you're gonna have to figure out what each of those dials particularly means. This is using more of a standardized metric, but just because it says this doesn't mean that it's actually like 100% this. You can't really take these settings on this Harbor Freight welder and apply them to the Miller welder and expect it to weld exactly the same thing. This is just basically a baseline to tell you where you are more or less, and then you can adjust it depending on what welder you're using. Just because you don't have a digital display doesn't mean you can't get a baseline for your welder. You could always look online to see what other people are using for their same exact welder. Do keep in mind that different brands of wire will react a slightly different way. So this is the settings that it told us to run for 16 gauge. Let's go ahead and set this up on the tripod and see if it works. This is probably the easiest way to practice how to weld, because this will do 2 things. Number 1, it's actually going to let you know that the machine is functioning properly and everything is the way it's supposed to be. So before you even start welding beads or anything, just do spot welds, hold your gun in one position, pull the trigger. If you're getting any kind of interruptions, if it's not holding the weld, if it's like turning off and on, check the machine, check your connections, make sure the wire's coming out the way you have to, and then you start playing with the settings. Start turning up the heat, start turning up the wire speed. If you start feeling resistance in the wire, that means you went too far. Go ahead and turn it back. If the puddle is just building up but it's not expanding wider and wider, that means you're too cold and you want to go ahead and turn up the heat. You got to remember that wire speed also determines penetration. So higher wire speeds also mean deeper penetration into the metal, because as it's turning into a pool, the faster wire speed is digging in deeper into the metal to get that extra penetration, versus a slower wire speed, it just starts melting up on top. So you guys gotta find that balance. Okay, so this is the result of the settings on the Harbor Freight welder. You can see that the flux is coming off pretty cleanly, not great. It doesn't just kind of like fall off, which it kind of should. So what I'm going to do now is I'm actually going to turn up the heat, see if we can get a better layer of flux. Alright, I've turned up the heat just a tad, and you can see that it looks much better. So let's go ahead and try to take this slag off. Look at that, you see that? It just peeled right off. Let's turn it up a little bit higher to see what the result of that would be. Alright, I turned up the heat the same distance that I went from here to here. I went from here to here, and look at the huge change in the result. The slag is pretty much non-existent because we kind of burned off all the flux. It ended up being really molten toward the end, which tells us that we're overheating the metal way too much. And then we actually ended up burning a hole, not even in the middle, on the side of it, because you can see that all this edge right here is actually being sunk into the side because I started melting the entire piece of metal. If you guys turn this on the side, you guys can see that I had minimal heat spread on the middle one, but a ton of heat spread on the side, and we had even more heat spread on the back. How is it possible that the first weld with less voltage ended up putting in more heat than the one that had more voltage? And the answer for that is travel speed. Travel speed is a fundamental component of welding. I talked about it a lot during my video on how to fix up your hand control, link somewhere above here. And basically what it does, or what it is how fast you move and how close you are to the given base metal. So on this one, because I was welding a little bit too cold, I was giving it more time to heat up and spread out, and because of that I was putting more heat into the material, as you guys can see here. This one I added more heat, but I was able to move a lot faster while also putting in less heat into the material, which means less heat, less warpage. You still have plenty of heat in the area that you're welding. And on this last one, you have an excess amount of heat simply because you're melting the entire material around it, and you can tell right here that you're putting in a lot of heat in the metal as well. So we're going to go ahead and dial it back to the settings that I had before. This one was a 17.5. The previous one was 17, and the original one was 16.5. So we're going to go ahead and put it back to 16.5 where we had it before. And I'm actually going to go ahead and turn down the wire speed about 5. So we went ahead and put this back to the original setting, and we turned down the wire speed. So turning down the wire speed actually had a similar effect as raising up the heat. So we're going to go ahead and take off this slag, and it doesn't come off nearly as easy, but it comes off easier than the original one, but it doesn't come off as easy as the second one, which is probably the perfected one. So what we're actually going to do now, we're going to go ahead and just increase the voltage a little bit. So we kept it at 105, and we're just going to go to 16.7. and see what that does for us. Alright, so this is what this next weld looks like. As you can see, it's an uglier weld than the previous weld. Slag doesn't really want to come off. And it looks like we have areas of molten metal, such as here and there, which means we are getting this thing too hot. And as you can see, we've got plenty more heat than we had before, but not as much as the second one. But the second one had a nicer weld than the last one did, even though it put more heat into the material. And then this is what I mean, that it's got kind of the seesaw effect. You can get a very similar quality weld forwards and backwards depending on how you want to do it. It just depends on how much heat you're putting into the material. This is a very simple yet complicated video. It took me a little while to actually understand all these concepts, and I hope I broke it down easily enough for you guys to understand. You guys know, if you guys have any questions, go ahead and put them down below. I'll see you guys all in the next one. Night Wrencher out.